So equivalent expressions. In order for two things to be equivalent means that you could simplify them and they both end up being the same thing. So when you simplify 4x minus x, you get 3x. And when you simplify 6 minus 2, you get 4. So those two would be called equivalent expressions because they're the same when we simplify them. So we did this last time, but here it is again. If we wanted to write three expressions equivalent to 3x minus 9, I think we ended up writing even more. All we have to do is think of things that when they simplify, they end up with 3x minus 9. So one of them, we did 2x plus x, because that made 3x. And minus 6 minus 3 makes minus 9, so that would be an equivalent expression. The 3x plus 9 minus 18, the 9 minus 18 is negative 9. And so when those like terms are together, it matches up with 3x minus 9. This dividing one, remember when you divide each term by the 7. So 21x divided by 7, while 21 divided by 7 is 3. And then you have minus 63 that would divide by 7. And 63 divided by 7 is negative 9 as well. Okay, so if we're trying to show if two things are equivalent to each other, we either have to simplify them and say, yes, they are the same. So the first thing we would try to do is, can you simplify 2x so that it looks like x squared? Or could you simplify x squared so that it looks like 2x? If you don't know how to do that, to show that something isn't equivalent, you just have to find one value that makes it not work. So for example, if I choose 3, if x is 3, what does 2x equal? If x is equal to 3, 2x is equal to 6. But if x is equal to 3, what is x squared equal to? 3 squared, which is 9. Are they the same? No. So you can show with one example, you could show that they're not the same. Because if two things are equivalent, they have to work for every example. So if you can find one example where they don't work, that would show that they're not equivalent. Why would 2 be a bad example to use? Because 2 times 2 is 4, and 2 squared is also 4. So that wouldn't show that they're not equivalent. So you have to find a value that does show that they're not equivalent. Is minus x minus 3 equivalent to 3 minus x? So if you think that they're not equivalent, you can start picking values. Plug in 5 for x, see what it equals. Plug in 7 for x, see what it equals. And if you start doing that a couple times and every single one that you try appears to be the same, then you might say, well, what could I do algebraically? What could I use from my rules that I've learned before to change one to see if I can make it look like the other one? It can't be right. Why?
Because the negative in the bracket makes that plus, so technically that's x plus 3, not 3. It's equivalent. It can't be equivalent.
Okay. So some people are saying it can't be equivalent. Some people say it is.
It's equivalent.
So how do you know it is?
Because when you use the subtracting, I forget what it's called.
This part?
Yeah,
So when you're subtracting something, that goes to both. So that'll be minus x plus 3. And doesn't matter the order. Is 5 plus 2 the same as 2 plus 5?
Yeah.
So if I write this with the 3 first, they are the same. Okay. I'm going to get a worksheet to practice this.